Assalamu alaikum everybody. So I would like to make a short clip showing you how you can solve the lab session easily using some website. So this is the lab I sent you today, and what we are interested on is this graph for what we call TX diagram. We need to create those TX diagrams, and the data are created, or this TX diagram is created from the data we have. So this is kind of a seismic shot together. We have the shot somewhere here, and those are the traces recorded by different geophones. As you remember, we have 94 geophones, and the spacing between one geophone and the next one is 1 meter. So this section totally from 0 up to the last geophone is a 94 because there are 94 traces. But the length of this whole section, because it's extending one more like trace, one more space, one more meter. I consider it 95. I consider that this is 95 meters. So from here to here is 95 meters. So how you can solve it? If I go to Google Classroom, Google Classroom, I sent you this link just right now. General Geophysics course. Let's go to coursework. And this is the website. This is the website which will help you calculating the velocities of respective layers and also getting the intercept time. So if I go back to this seismic shot gather, I need only the seismic shot gather itself. I don't need the numbers. So I make a snapshot. I open this application, snapping tool. I think most Windows have this thing, snapping tool. You just type search snapping tool in the search bar and you'll find it. Let's create a new, and I just select the area I'm interested or the area of the data without the access numbers. So that's how it's supposed to be. Let's try to make it perfect. Okay, so I save it, save as. I already have a copy here, my desktop. So I rename the original one with the new one. Save it, yes. So I have it right now in my desktop. If I open the desktop, this is the desktop. I think I sort them by date. Yeah, I think that's the one. So you right click on it and you select open with photos. So this is exactly what I made right now from the snapshot. I would like to rotate it. So I would like to make it upside down. Rotate once, rotate twice. I rotate it twice and I flip it. So source, instead of being to the right, I would like to make the source in the left direction. I flip it, just do that. If you have this application, it's installed by default in my computer. I haven't done anything. And I think probably you have it too if you have Windows 10. So let's make a copy or save the copy and replace the original one with the new one, with the one we made editing on. Yes, I got this one. So if I right now go back to this application, it's an online application. You don't need to install anything. What you do, you go here in this plus sign. You say I need to import an image. Get your image, choose the image. This is the option, choose a file. And in my case, it's on the desktop. I select this one, open. Okay, that's it. But there's some tweaks I would like to make, especially on this grid. You right click on the grid, you'll find the last option saying graphics with a gear icon. Click on it, go to axes and choose only positive. So I don't want the negative x-axis. Do the same for y-axis, select only the positive. And close this one, bring it a bit down. So in my original figure, if I go here, I see this point is 0, 0 for x-axis, oh, sorry, x-axis and y-axis. So it's 0, 0. Let me draw so you understand what I mean. Save it as new one, name it to capture to PNG. And let me go again to desktop. Do I have it? I have it, yes, that's the one. I open it with photos, edit with photos. I apply the same principle, rotate one, rotate twice, and flip. That's what I have done. So this is the time axis. This is the x-axis or distance or offset axis. I keep this one open so you see what exactly I'm doing. I have this one and I have also this one. So this point is 0, 0. I want to change A. You see where A is? I want to change it to 0, 0. So let's maximize this one. Let's see where A is. A is right now is 0, 0. Where B is supposed to be? B is supposed to be on 95, according to what we see here. Or exactly, I think here. So this is 80. B, the last point here, is supposed to be on 95. This last trace itself is 94. Add 1, gonna be 95. So back to here. So for B, case B, Y is 0, but X, what is the X is 95. It becomes a bit bigger. Just zoom out. And I need to add another point. How you add a point? Click on this one, a point, click anywhere, and go back to this mouse click. So you don't accidentally create many more points. So if I keep clicking, because I selected points, it will keep creating new and new points. And right now I'm selection mode. So this one, for this one, I need to bring C here somewhere. Supposed to be along the 0 y-axis. Sorry, 0 x-axis. That's the 0 x-axis. So x gonna be 0, but y is supposed to be 0 0.1. 0 0.1. So you see it's there. It's somewhere there. The box D. That's how it. Why I need to make it 0 0.1? Because that's what I see here. 0 0.1. C is supposed to be 0.1. And what shall I do? I click on this one, figure. That's the picture. I can rename it whatever I like. That's the default name I got when I imported the figure. Oops, sorry, I made a mistake, I think. Yeah, that's good. So I click on this one, setting, go position. So corner one, which is this corner, is on point A. Corner two, which is this corner, is on B. And corner four is this corner. So corners are usually for any rectangle is one, two, three, four. And that's corner four. So corner four supposed to be on C, where C is here. So it shrunk, it becomes very small figure. If I keep zooming, you'll find it. So what I should do right now, I need to create some exaggeration. I need to create some exaggeration within my grid. It simply can be done like that. Let me close this one. Right click anywhere here. Go to settings. Be it's still within the figure. Graphics. Graphics. That's the setting of the axis. And in the basics, so right now there is no exaggeration. It means that x scale is equal to the y scale. Make it like 100. Let's see what happens. So it's getting bigger. So right now in here, this 1 is equal to 100. The 1 in x-axis is equal to 100 in the y-axis. Or the opposite, sorry. 1 is equal to 100. So 0.1 equals to 10. Let's make it a bit bigger. Let's make it 1000. See, yeah, that's better. So I can work with this one. I made some exaggeration. That's exactly how it's supposed to be scaled. So from 0 up to 0.1. And this is from 0 up to 95. And let's draw some lines. You go here, line. This is supposed to go through 0. So click on A and rotate the mouse or rotate your lines till it becomes passing through the direct energy. This high amplitude represents the direct energy. Just click it once, it's done. Okay, I made a mistake. Let me delete the other one. E. Oh, I'm creating random because, yeah, that's good. I got one. Let's make another one for the refracted one. So line, I click here once. I think this is bad one. I need to delete it. Yeah, let's delete E, F, and the line. If I select this one, move E, F, and G, delete from the keyboard. Let's make it again line. That's better. So I have my two lines. This is passing through the direct energy, and the other one is the first refraction. Sorry. So I have two layer case. Let's do something before doing anything. Go back to move mode, simple mode, and let's change the color of this one, the G line, setting color, and make it something like red. Do the same for F line. That's the first line, direct line. Setting and color, make it, let's say, blue. So that's what I have. This is the equation of these lines. This is the equation of direct, and that's the equation of refraction. Did I change the color of this one? This one have been changed here. This wasn't changed yet. The direct haven't been changed yet, so I go setting, color, make it red. Oh, that's red. So let's represent this as a straight line where y is one side and the other expression is on the right side. Y is in the left side. So we know what is the intercept and what's the slope, because the equation of a line, straight line, is simply like that. So y equal mx plus b. In this case, because this is passing the direct ray passing through the zero, there is no b. B is zero, but there is a slope. So we need to find the slope. Slope is the reciprocal of velocity in this case. So this slope gives you the velocity of the first layer. This one, the refraction, gives you the velocity of the second layer. So usually, whenever there is anything related with math, I open Python. You don't need to open Python. You can do this manually. But just for the sake of simplicity, I usually like to use Python. So the way I use Python usually, let's say IPython, or you don't need to do it in Python. You don't need to because you don't have Python installed. But since you have the equations, you can work with the equations themselves. Let me see, go to your course. Anything in here, Python? Is that your course? Yes. So let me create a new file, call it Python. I go there and I open a Jupyter. You don't need to know these things at all. This thing is not necessary at all. What you need to know is simply how to draw these things. This is more important than Python for your case. So I open a folder. First thing I do, just import some function and some libraries. Py sim, let's import. I imported SymPy. So I mixed some expression xy equals SymPy dot symbols xy. X is simply x, y is simply right now y. Because if I right now type xx, it gives you an error. They are not known. I need to create them first. So I created them. Let's see my expression. So my expression says, that's my expression. Let me bring it here. And this one's supposed to be here. So I can easily work with them. So that's my expression. Let's create the first expression and name it whatever expression is equal to minus 0.3 times x plus 32.11 times y. So this is the first expression. The other side is 0, so I don't care. and expression, that's the expression that's equal to this one. So I need to solve this one in terms of y. What you can do, you can bring, if you are doing simply without Python, you can bring this to the other side and divide then by this value. So you can do simple thing like that, equal, then after that you do y equal divided by this value. That's what you do without Python, but usually I want to do it in the hard way. I get used to Python a lot. So usually whenever there is any math, any expression, I go right away to Python. So I can, because if it's very difficult expression, then you need some like skills, programming skills. I say SymPy, that's my package. Solve, let's solve this one, this expression in term of y. So that's my expression. So that's the value I said you need. That's the slope. 1 over this value is the velocity. So that's the velocity of which, that's the velocity of direct, because there is no intercept. That's the velocity of the direct. Let's right now calculate the velocity of refraction. That's the expression of refraction. This is the expression of the refraction. Let me see if I can copy it. I'm not sure. Just let's write it. I do this one again, but name it expression 2. Expression 2 equals, in this case, is 0.02 times x plus 58.12 minus, because I bring this one to the other side, becomes one expression, minus 1.07. I bring this one to the left side. This is expression 2. So I do the same again, same pi. And in this case, I just type 2. And so this is the intercept. That's your intercept. This is this value. It's equal exactly 0 points long number. So you see how accurate Python is. And that's the other number, the reciprocal of the slope or velocity. The slope, but reciprocal of velocity. This will give you the velocity of the second layer. 1 divided by this value is the velocity of the second layer. So that's the velocity of the second layer. Interesting, it's a good number. So you can take this number. So you can take this number. Let's calculate this velocity. Let's calculate this velocity. This is the one you see here. It's going through the origin actually. So I can even trust A. Let it pass through A. Somehow it's shifted. Let's delete this one. Let's make it 15. I draw this one, but I delete them. G, H. I delete them. And I draw it again. I will not pass through A. That's better, I think. And let's give it a different color. Let's give it this color, probably. Yeah, I think this is good. Let me adjust it a bit. Yeah. So this is the expression. I bring it here and do the same thing. The expression 3, I name it. So it's supposed to be minus 0.3, 3, and that's 11, 11.7, and the last one is 0. So this was in the other side. When I bring it to the left side, it becomes minus. It was positive, it becomes minus. And I need to round this. We call this thing cells. And let's do the solve thing or the magic senpai does. And I name this one expression 3. Let's see how the velocity is. Yep, that's close to the velocity of, you know, we answered that during the lab too. That's quite close. Maybe if I bring it to the origin, it becomes way closer, like 320 probably, or 330. That's way closer to the velocity of air. So that's just the thing I would like to share with you, how you can use this tool. I sent you the link in Google Classroom. Make use of it. It's very simple. So you see, within, like I was explaining, if I wasn't explaining, might have solved it way earlier within very short time. Hope what I made is useful to you, and see you next week.